Before I start, I just want to say a quick thank you to Chris and the team. It's a real privilege to stand here and be able to talk to a software community and share our ideas, and I'm really grateful for the opportunity. Today I'm going to talk about scaling humans with the software development lifecycle. The clicker actually doing anything? No. Big green button, right? Maybe you guys can press a button for me. I'm going to run through this real fast because we're being asked to sort of make up a bit of time. Big green one. Anyway, if they can hit the button for me. I work for Westpac New Zealand at the moment. Now we're flicking right through it. That's all right, we can skip over the introduction. I've been doing this for a while. I know some things, and I'm going to share some stuff. I'm going to start with a paradox today, and that is that we effectively all turn up wanting to be successful at work. Now, success looks different to different people. To some people, that is promotions and pay rises. To other people, it is recognition. To other people, it is making a difference in the world. But we all want to succeed more or less. The flip side of that is with large numbers of us turning up wanting to be successful, we often fail. Projects go over budget, they go over time, sometimes they fail really spectacularly. And the Airbus A380 is a really good example of this. If you've ever flown on this plane, it is a feat of engineering. The wings are made in the UK, the fuselage is made in Spain and in Germany, and the nose is made in France. Now, Airbus put together a whole bunch of infrastructure to move all of these massive pieces into Toulouse in France to put it together. And in 2005, when the first pieces of that first plane arrived, they assembled it all, they ran all the wiring through the frame, and they went to connect it, and it was too short, 2 feet. Couldn't connect these things together. Can you imagine Airbus's surprise? Now, that cost them 5.5 billion euros. Set the project back by 2 years. They had to go right back to the drawing board with all of the design of all that wiring. 5.5 billion euros is about 11 billion New Zealand dollars. And in 2005, that was 6% of our GDP on a single mistake. The engineering talent at Airbus is undeniable. They had world-class engineers working for them. They were backed by some really sophisticated software, and yet they failed. So how? Excuse me. W. Edwards Deming was one of the people who pioneered the idea of looking at organisations as a system. And he said that basically a system will overwhelm even the best people if it is poorly designed or if it is flawed. So if we follow that train of thought, and if you were listening to Andrea's talk earlier on today, she mentioned a gentleman named Russell Ackoff. Now he really championed the idea of systems thinking, and I'm kind of jealous that I didn't take Andrea's quote and apply it to this slide. It is entirely possible to model human systems as software. We can look at the processes and the interactions between the people, and Microsoft even gives us the tools to do this. We can get some Power Apps, hook them into Office 365, Outlook, Teams, and very quickly we will see where the data flows, who it flows to, who our go-to people are, and who they are not. And gaming's been doing this for years. We've modelled good, bad, and ugly interactions of humans throughout gaming systems for decades. It wasn't Facebook building a metaverse, which was the digitisation of human interaction. So if we accept that human systems can be much like software, then we can actually look at the complexity of software and compare it to the complexity of human systems. Our humble monolith, when it became scaled enough to be useful to an organisation, became really difficult for us to understand. We had to put really sophisticated debugging techniques to understand what that thing was doing in production. But that wasn't cool enough. We decided that we needed to take something that worked in process, in a single memory space, pull it apart, and throw it all over a network. And when we did that, we took all the complexity of that monolith, and we added latency, eventual consistency, concurrency, multiple points of failure. And we made it really hard on ourselves to understand what was going on. And then you have Netflix. Their system is so large and so complex that no one person really understands how that thing works. They don't even have a test environment. Their system is so large that it just wouldn't be economical to do so. And even if you did, how can you replicate the scale that Netflix runs under? How conclusive are your tests going to be? That brings us to Conway's law. Melvin Conway told us that our software is actually just a reflection of the organisation that builds the software. So if we took Microsoft's tools and we applied them to Netflix, what would that process map look like? Even if we took that process map and applied it to a smaller company that built a bunch of microservices, what would that look like? It'd look like this. It'd be horrendously complex. And the reason for that is when you're dealing with human systems, entry level of complexity is a distributed system. Each person in your organisation is more or less a little autonomous service. You've got an engineer service, a PO service, team lead service, and between all of those is a network of communication, data flows, eventual consistency, latency, all the things we spoke about with distributed systems. But humans are non-deterministic. They have feelings. They will come in today and they will make a different decision today because it's raining in Glum. Tomorrow it'll be sunny and happy, and they'll make a different decision when asked the same question. And when you are working with these sort of systems, it is actually impossible to predict the outcomes of the changes that you make to it. There was a gentleman named Edward Norton Lorenz, and he came up with this quote. Now this is the Hollywood version, because this comes from a movie of the same name. And if you haven't seen the movie, it's really good. It's getting a bit old, but really good. But Edward Norton Lorenz was a mathematician, and he also modelled weather systems. And what he found was when he modelled these weather systems using mathematics, when you made really tiny little changes to the inputs, you ended up with massive fluctuations in the outputs. He was the father of chaos theory, and these are chaotic systems that we're dealing with. There are a couple examples I'm going to give you about why these systems are so difficult for us to reason about, but understand this is just a couple of examples. There are hundreds of these that will catch us out. The first one is Goodhart's law. Charles Goodhart was an economist, and in the mid-1970s he wrote a paper about UK monetary policy. And in that paper, he wrote that when a measure becomes a target, it is no longer a useful measure. You might wonder what UK monetary policy has to do with software, but in 1996, another research group grabbed that quote and they applied it to systems of accountability. And if you work for an organisation, you work under an accountability model, so this applies to you. Now, a really well-known example of this is the Cobra effect. In the early 1900s, India was under British rule. And the Raj at the time was super uncomfortable with these really venomous snakes slithering around the place. It's probably just as well he didn't go to Australia. He decided that he was going to put a bounty on dead cobras. And the locals duly went out and started slaughtering cobras. But like generations that came before them, they understood that the most efficient way to supply the government with their insatiable thirst for dead cobras was to farm them. And they did. So the Raj noticed this, and he's like, well, this is not what I signed up for. I wanted them to kill wild cobras, and he pulled the incentive. And when he did that, there were a bunch of farmers that now had thousands of head of cobra that were worthless. And it was going to be very messy, time-consuming and annoying to slaughter them all and dispose of the bodies. The government didn't want them anymore. This is a native animal. It's much easier to open the gates and let them go. That's what they did. So the net effect of the Raj's incentive was actually to increase the cobra population in India. This is known as a perverse incentive, and it's a perverse incentive because it results in the opposite outcome of what you were asking for. Tell me if you've seen somebody at work that has been incentivized to meet a deadline, hire a certain number of people, cover a certain number of lines of code. And I guarantee they've met those requirements, but at what cost? Another example is the Hawthorne effect. In the early 1920s or mid-1920s, there was the Hawthorne Electric Company just out of Chicago, and the management team decided that they were going to do some lighting experiments. The staff there worked on tiny little electrical components like relays, and what they thought is if we raise the light levels, people will be able to see better and productivity will go up. So they did. They raised the light level. They had a test room and a control room. Control room they left alone. The test room they played with light levels. The problem was that productivity went up in both rooms. And that was weird because they didn't touch the lights in the control room. The only thing that actually modified the productivity of the teams was when they lowered the light in the test room so low that it was kind of like moonlight. People couldn't see what they were doing anymore. And the productivity went down, but only in the test room. In the control room, it stayed elevated. The people had changed their behaviour because they knew they were being observed. They got less coffee, went to the bathroom less, maybe they worked harder, who knows, but they changed their behaviour. How many times have you seen somebody at work be a lot more polite on a call because the boss was on it than when the boss isn't? Or they dress nicer because the CEO is coming through the floor, right? We change our behaviour if we know we're being watched. These are 2 examples. There are hundreds. You cannot accurately predict the outcome of changes you make to a complex system. So how do we deal with it? We are all software engineers. All of you put your hands up. We're all developers. We deal with this stuff all the time. And we use the SDLC to do this. The software development lifecycle tells us a really simple thing. It tells us that if you want to make changes in a complex environment, you first have to plan it, and then you design it, develop it, deploy it, test it, deploy it, maintain it, and then live with it. But it doesn't tell us how often we make changes, how big those changes should be, or how we should go about it. And that's the realm of software methodologies. And if you look at Waterfall, Waterfall will tell us that we could build an entire application with one hit of the SDLC. These days, we tend to prefer much smaller iteration. We use Agile and DevOps. And it's those iterative sort of processes with fast feedback loops and the SDLC that we're going to talk about today. It's worth noting that it also works for hardware. SpaceX spent about 3 years crashing booster rockets. And every time they crashed it, they figured out why, they tweaked something, and they crashed it again and learned something new. But eventually they landed one, much to all of our surprise. I don't think any of us actually thought they'd pull it off. Now they do it all the time, we don't even notice. James Dyson, he built about 5,000 prototypes of his vacuum cleaner. He'd change it, tweak it, test it, change it, tweak it, test it, and eventually he landed on one that took the market by storm. These are not the only 2 companies. Boston Dynamics will be familiar to a lot of you. Tesla, obviously owned by the same guy as SpaceX, but there's also Rivian, Lucid Motors. There's a heap of companies that work this way. So if it works for software and it works for the hardware, why not the wetware? So what I'm going to talk about today is it's just a process, and you can apply this to a team, you can apply it to a bunch of teams, a whole floor, I'd argue even an entire organisation, although I've not done it at that level. We talk about just iterating over the system that our people work within, removing toil, removing blockers, and allowing our people to do the job that they were hired to do. The theory is, if we allow our people to succeed, then we will succeed. The first step's really easy. Where are we, and where do we need to be? That's a really loaded question. The system we're talking about here is not the software that we're building. It's the system that builds the software. So it's the people. And that's a really hard thing to understand when you say, well, where do we need to be? Where we need to be is for that system to be able to deliver the outcomes that we ask of it. So if we narrow our thinking down to an engineering organisation, is our engineering organisation able to deliver stable, resilient software in the timeframes that we're asking? And if it's not, then what do we need to change to make it able to do that? And I emphasise on here that it's a hypothesis. And the reason that I say it's a hypothesis is because we are working in a complex system and we can't predict the outcomes of our changes. So any prediction we make is just feelings. A hypothesis implies that it needs to be verified, and only upon verification does it become fact. Until then, it is just feelings. So the first step that we have to go through is implementation. The second step we have to go through is implementation. And this is arguably the easiest part of the process. If we're talking about human systems, then largely what we're talking about is a change in process, hiring more people, restructuring, it's these sort of things, right? So we have to design that process, or we have to procure the hardware or whatever. We have to go through that preparation phase. Then we roll it out. It might be a big hit, it might be roll out to certain cohorts, whatever, and then test. And this is weird because how do you test something that you've done to people or to a people system? But think about rolling out something like a new software package. You may have inadvertently bought the wrong licenses or not bought enough. And now the change you made is not the change you think you made. And you'll draw the wrong conclusions, or at least you'll waste an iteration if you pick it up in the next phase. I keep thinking I'm either at first or last. Middle one, and probably the most important, is that we need to monitor. Now the hard thing here is, what do we monitor? And this is where I like to lean on SRE. Before the days of SRE, we used to look at CPU, memory, network utilization, and these were the numbers that we cared about. If our CPU was hot, we got out of bed and we tried to figure out why. SRE told us, actually that doesn't matter. What matters is the end user experience. And if the end user is able to use our application, it's up, it's functioning the way that we expect it to, then if the CPU is burning at 80%, that's just a good return on our investment on that hardware. Only at the point that the end user experience degraded would we go look at the CPU or the memory or the network and try to figure out why that was causing the degraded user experience, but it was always the user experience that was the problem and the thing we focused on. So here, how do we know if our system's healthy? What are we monitoring? Can our system deliver the outcomes we're asking of it? And those are the things we need to monitor. And what were the effects of our last change? As I said, we can't predict the effects of our change. We can have feelings about it, and we make the change, and then we need to look and see what actually happened. And 9 out of 10, what we'll find is that some of the things we thought would happen do, some don't, and a whole bunch of stuff that we didn't expect does. And those are the things we need to pay attention to. And last but not least, we need to iterate. Have we made progress? And by progress, I mean, are we more able to deliver the outcomes that we were asking for? Are we stuck? Do we need to start again? Is the plan still good? And what do we do next? This is all great in theory, but a small sliver of an example, and before I give you this example, please understand what I'm about to describe is 2 really simple iterations of a program of work that took years and was a countless number of changes. But I started working at this company because of their location. The talent pool that they had to hire from was very, very small, and they were growing really rapidly, and their inability to hire was really hurting them. I was one of the early adopters, let's say, of being one of their first remote staff, and so I felt the most pain. Their processes were very much tailored around the cohort of 100 or so people that they had working in the office. And we needed to create a hybrid working environment where not only could the on-site staff work together well, but they needed to be able to interact with the remote staff as though they were in the same room sharing oxygen, or at least as close as we could get. One of the first things I noticed when I was talking to the engineers, I'd be behind my computer in my home office and they'd be on their mobile phone. Why are you on your mobile phone? Go grab your laptop. They didn't use laptops, they used desktops, because everybody thought laptops were too slow. But I knew that they worked from home. So how do you work from home? Oh, we've got 2. So I hypothesized that having desktop machines, or the policy of using desktop machines, was hindering the ability of the engineers, in particular, to be able to work with their remote staff or interact with their remote colleagues. So we duly went out and found laptops that were not slow. Turns out you can find some really fast laptops if you just up your budget a little bit. What we noticed was that one-on-one meetings were vastly improved. Now the engineers could take a laptop, they could take it into a meeting room, I could share screens with them, and it worked really, really well. But when we had a number of people in the meeting, and we had a handful of people in an office and a handful of people on remote, the people in the office took the privilege that you normally do when you're sharing oxygen, and they had heated debates, they butted in, they talked over each other, and they made it really difficult for the people that were online, because the people online were restricted by the ability of the tool. They had to put their hand up, be polite, and wait. And generally, they didn't talk, and they were very quiet. So we had really low engagement from remote staff. Unexpected side effects were that we had an increase in productivity. And that was because the engineers that were working with 2 machines would inevitably commit in one machine, forget to push, turn up at work the next day, and their changes are gone. They tried remedying that by remoting into one machine and having everything in the one place, but you were just one Windows update away from not being able to remote to that machine anymore. And that's real fun when you're in the middle of an incident and your engineer's trying to remote into their machine. Now they could just pick that machine up, take it with them, and have everything on the one machine. That was great. Productivity went up. But there was the next problem. They could pick that machine up and take it with them, and they did, to restaurants, cafes, airports. And they connected to all sorts of Wi-Fis, and we had our IP on those machines, and that was not good. So did we make progress? Well, yes. One-on-one meetings were a lot better. We done? Not by a long shot. We stuck? No. What next? The next thing we hypothesized was that having people on site in an office actually put them at an advantage to the people that were remote. So the change we made was we asked everybody, if there was a remote attendee, we asked everybody to use the online tools. So everybody dials into Zoom. It doesn't matter if you're sitting in the office and there's 5 of you, you all dial into Zoom, you all put your headphones on. And now we even the playing field. Now everybody has to put their hand up, everybody has to speak in turns. Effectively, everybody has to be polite. And that worked really, really nicely. But then he went into the office, and it was like being in a call centre. Because now the 3 engineers that were previously sitting in an office or in a meeting room were sitting at their desk with headphones on and talking. And that's a really bad environment for engineers to solve really complex problems. So that was something else we needed to solve. I'm going to stop iterating here because there's a limited amount of time. But as I said, this was a couple of years worth of work. There were countless changes, and it didn't just focus on making meetings better. If anything, we wanted to make meetings go away. So a quick summary is that, remember the butterfly effect. Take small iterative steps. We know that in software, if we do 6 months worth of change and then yeet it out the door, we're in for a really bad time. Human systems are more complex than the software that they build. And if we make massive changes to a human system, we are going to be in for a very bad time. Stay focused on your long-term outcomes. Long-term outcomes do not look like the number of lines of code you cover with unit tests. They do not look like a number of Jira tickets that are closed. Keep your eyes on the road and don't drive off it. Which leads me to the avoidance of management by numbers. If you set a numerical or a date target to somebody, what you have just done is defined success. You have taken a number and said success equals this. Anything less than this is failure, anything over this is success. And they will meet that number, and you will not be able to stop them, and they will bulldoze everything else in their way to meet that number. So please don't set numerical targets for your staff if you want to succeed. And if I can give you a glimpse into the future, I talked a lot about AI. It's not going to be long until we are working in hybrid teams. We will have engineers and we will have their software counterparts. Microsoft in November last year released a system called Magentic One. It was a research project, and it's a generalist multi-agent system that is capable of solving open-ended problems. It's super cool. Please go and have a look at this. But what's really cool about it is that the process loop that it uses is very similar to what I've spoken about today. It makes a plan, it takes a step, checks if it's making progress or if it's stuck, and it keeps looping around until it either succeeds, and if it doesn't, it bails out and says, let's try a different plan. It's pretty much what I've spoken about today. And the encouraging thing about this is if we are running teams that are hybrid between humans and their software imitations, it makes sense that we need a process that's going to work for all of these implementations of people. Do have a look at this, it's super cool. The key takeaway I would like you to take out of this is that what we've spoken about here today is the software development lifecycle, which is systems thinking in a very, very narrow context. Now, if you take that narrow context and you expand it and you apply it to human systems, then you are right back at the works of this guy, Dr. Deming. Dr. Deming, I would go so far as to say that he pioneered looking at organisation as a system, but I can see Andrea looking at me, probably not quite right. Akov is another guy who really championed this. Akov and Deming really respected each other's work, but they do come at it from slightly different angles. Go and have a read about this guy. He's the sort of paradigms that he talks about and how we look at our organisations and how we manage those systems and remove toil is really insightful, and he's well worth a read. And I've managed to save everybody about 5 minutes and get you back to your talks. Thank you very much.